Okay, so what we discussed yesterday, so we considered this function f from R to R, f of x is equal to x upon square root of 1 plus x square. Then we proved that it is 1 function, right? Fx is equal to fy implies x is equal to y. So function is 1. Is it onto? Is it onto?
No, sir.
It is not onto. So therefore, what we came to, so thus what we came across, if y belongs to -1 and 1, then there exists x in domain such that x is equal to, what is the preimage of y? What is the preimage of y? What is preimage of y? Either you choose plus or minus, anyone. Y upon square root of 1 minus y square, or x is equal to minus y upon square root of 1 minus y. There are, you once you choose minus, then every time you should choose minus, right? Or plus. So then is it preimage? So if I choose preimage of y as square root of 1 minus y square, right? Is it well defined? Because denominator, see, this is well defined because denominator is never 0 and never negative, right? 1 minus y square is always greater or equal 0. Why? Because y belongs to -1 to 1. We are just saying y is in -1 to 1. If x is equal to this, then is it the preimage? So let us check what is f of x. Does it gives us y? Right? So what we are doing, we have selected y and we want to produce x in domain, but we are saying that x is nothing but y upon square root of 1 minus y square. Either you select minus or plus. There are two possibilities. Once you select minus, every time you should select minus. Right. Anyway, is it the preimage of y? That means what is x? X is y upon square root of 1 minus y square. Right. But what is it by definition of function? By definition of function, what is the value of, see, value of function at x is x upon square root of 1 plus x square, right? And then what is the value of function at this number? What is the value of function at this number? This is a number, y upon square root of 1 minus y square. What is the value of function at this number? Correct? What is value? So this number, what is value at x? X upon square root of 1 plus x square. So what is the value at this number? This number upon square root of 1 plus square of this number. Correct? Whatever I am writing, is it clear? Yes. So y upon square root of 1 minus y square as it is. In the denominator, what is it? What is in the denominator? Square root of 1 plus y square upon 1 minus y square. And simplify this further. Simplify this further. Y upon square root of 1 minus y square is the numerator, and denominator 1 upon square root of, what is it?
Plus minus. Uh,
Is it 1 upon 1
1
minus y?
upon max y square.
So y upon square root of 1 minus y square into square root of 1 minus y square, which is y. Correct? And therefore the preimage which we have obtained, x is equal to y upon square root of 1 minus y square. This is actually the preimage of y. right? Because if we apply function on this preimage, we get back y, right? So x is the correct preimage. Okay, so I will summarize everything what we have done. Thus, f from R to R defined by f of x is equal to x upon square root of 1 plus x square is 1 1. First thing we have already verified, right? Range of f. What is the range of f?
-1 to 1.
-1 to 1.
-1 to 1, because every element inside -1 to 1 has preimage outside this. So range is this, correct? Third point, for y belongs to -1 to 1, the preimage is x, which is equal to y upon square root of 1 minus y square. If x is positive, then preimage is so you select preimage minus or plus. Once you select minus, then that is throughout you have to select minus. So there are two possibilities to select preimage. That doesn't mean that x has two preimages simultaneously.
Sir,
Yes.
sir, how did we found the range of the function which is -1 to 1 open interval?
Okay, go back to the yesterday's calculations. Right. Suppose we selected any y from the codomain, right? And we wanted to find x in R such that fx is equal to y. In that process, we found x, which is preimage of y, but that preimage is possible if the denominator is well defined. When denominator is well defined?
Only on the positive,
Ah,
real numbers.
so 1 minus y square is positive. That means y square is less than 1, means y is between -1 to 1, right? So
Yes.
for y in codomain, it is possible to get preimage if, only if y is in between -1 to 1. That is what we discovered yesterday, right?
Okay, sir.
Fine. And another observation is here, ki f of x is equal to x upon square root of 1 plus x square. That means from this calculation 1 plus x square is greater than x square. So take square root, divide. So x upon square root of 1 plus x square is less than 1. Similarly, if x is negative, we can prove that it is greater than -1. So all fx lies in between -1 to 1. So range is -1 to 1, that you can actually check. But f is not onto because range will not cover entire codomain. Correct?
Yes, sir.
Fine. So one more observation, f is not onto because range is why the range of f is not whole codomain R. It is smaller, right? Can you draw the graph? Can you draw the graph of this function? Can you sketch the graph of this function?
It will be a sinusoidal curve.
Uh, Let us see what is it. 1. This is x-axis, y-axis, and -1. So observe one thing. What is fx? Fx is x upon square root of 1 plus x square. So if x is positive, can you say that x upon square root of 1 plus x square is also positive?
Yes, sir.
And if x is negative, that means if x is positive, fx is positive. And if x is negative, fx is negative. Therefore, if you look at positive values of x, then function is positive, and you see that key function is like this. There are other techniques so that nature is exactly, and it is going towards in this way. It is, and function is 1 1. So the situation is not like this. If situation is this, then function is not 1 1. Remember this, because there are, by horizontal line test, there are 2 points with same value. If function is going up and again going down, that is not going to happen in this case. Why? Why that is not going to happen? Because function is
function is 1 1.
so if it is going up and again going down, the 1 1 ness will collapse. But this function is 1 1. So anyway, the mountain line situation is not going to happen, right? So, and at 0 function is 0. So it is passing through 0 0, and it is going like this because it is positive. And on negative side, the nature is similar. But when this graph of function will meet the line y is equal to 1 or y is equal to minus 1, do you understand this? When the graph will meet this line, horizontal line y is equal to 1, this is y is equal to 1 line, and this is y is equal to minus 1 line. So this graph will
At
meet
infinity.
at infinity. Very good. So graph will meet the horizontal line at infinity. So it is keep on increasing, but it will not meet the line. It will meet at the end of the universe, means at infinity. Right. So this is a graph of function. This is important information we got from above discussion. Right. And therefore, if we define f from R2 minus 1 to, so I will just restrict my codomain to be minus 1 to 1 by fx is equal to x upon square root of 1 plus x square. Then already this function is 1 1. Then what can you say about this function? What can you say?
It is
This
1 1
is
and
1
on 2.
1 and on 2.
Then f is 1 1 and on 2. 1 1 is already proved, and on 2 because range is entire codomain. Therefore, every point in minus 1 to 1 has pre-image. So function is on 2, and hence f is bijection. F is bijection. Now there is a bijection between set of real numbers, that means whole line, and small interval minus 1 to 1. What it suggests from previous discussion, right? This is line, and this is just interval minus 1 to 1. And f is a function from this to this, and bijective function is there. So if there is a bijective function between two sets, then what we can say?
Their cardinality is same.
Cardinality is same. Therefore, the cardinalities of R and minus 1 to 1 are same. That means how many real numbers are on line? As many points on the in this interval. So therefore, real line and this interval is equivalent in some sense. Equivalent means the number of elements is same. Number of elements is same means what? So if we define a function, I am going to define a function g from minus 1 to 1 to R. And what function I am going to define? G of x is equal to x upon square root of 1 minus x square. What can you say about this function? Then g is 1 1 and on 2. How do I define? Because I know that if I want to go back from minus 1 1 to R, right? So by previous discussion, if y is here, then what is the corresponding x here? I can produce it, right? And what is the process? You understand? By previous discussion, if minus 1 to 1, y is in this, then how did we produce x in the this case? If this is my f, then how did we produce x? Y upon square root of 1 minus y square. Is it clear? Corresponding pre-image under f. But now I am defining function from minus 1 comma 1 to r. And what is my function? X upon. So this function is also 1 1 and on 2. Check this. Right? So you need to check this. Fine. So what actually these functions are doing? They have same number of elements because minus 1 to 1 interval and real line have same number of elements because there is a bijection. That means you take a small interval minus 1 to 1 and we can convert it into the infinite line. This is what the meaning is, right? Take a smaller interval minus 1 to 1 and convert it into infinite line. And what is the process? Process is this function g, or other way you take infinite line, can you convert it into a small interval minus 1 to 1? Yes, just apply this function. So mathematically it is possible to compress a real line to small interval, or you can stretch like rubber interval minus 1 to 1 into line. This is what the mathematical mechanism going on in this case. Is it clear? Right?
Yes, sir.
So if you take rubber, elastic rubber, you can stretch so that length is increased, but the number of particles in that rubber thread are not going to change, right? Therefore, basically small interval or large interval doesn't matter. So, but you can stretch it to infinite line. That is what we can learn from this. Okay. And therefore, there is a bijective function from small interval. So therefore, there is a bijective function from small interval to infinite real line. Can you tell me graph of g? Graph of function g. So what is the graph of function g?
Interchange the axis from the graph of f of x.
Just you draw the graph of function f and just see this graph from back side of your node page and just rotate by 90 degree. So graph of g is just interchange the axis. Graph of g is this, right? This is a graph of g, function g, and observe that this function is also 1 1 and on 2 because it will cover whole line because it is going up to plus infinity and graph is going up to minus infinity. So it is 1 1 on 2. Okay, so did you see such type of graph somewhere else?
Tan function.
Graph of tan function.
Right. So what is the function f from what is the domain? Minus pi by 2 to pi by 2 to r. And what is the function? Fx is equal to tan x. And then this function, so this function is 1 1 on 2 and therefore the number of elements in interval -1 pi by 2 to pi by 2 is same as R. So there is this a bijection, and F is a bijection. Right. And what is the opposite reverse process? If we define G from R to minus pi by 2 to pi by 2, G of X is equal to tan inverse of X. This is the opposite process. And what is the graph of this tan inverse function? What is the opposite process? Then G is bijection. G is bijective function, and if you observe the graph of this function, then graph of G is this graph of G, graph of our previous functions, right? Correct. Now the question is, if A less than B, then does there exist a bijective function f from interval AB to R? Does there exist bijective function from interval to R? What is your answer?
Yes.
Yes. So the process is, from our yesterday's discussion, we can observe that from AB to -1 to 1, this interval, does there exist a bijection? Does there exist a bijection from interval to another interval?
Yes, sir.
And we know that there is a bijection from bijective function h from this to this. And can you combine this process? Can we combine this process? Right. Is it possible to combine this process? Combine means what? Then the combination of these two processes is a bijective function from AB to R. And this is what we want to learn further. Is it clear what is the idea? What we want actually? Yes.
Yes, sir.
Right. So this is our aim, how to combine two processes together, and what are the, you know, the G, you know H, you know properties of function G, which is going from this interval to this interval, and H is a function which is going from -1, 1 to R. And if we combine these two functions, then what are the properties of this new function, which is a combination, right? So what do you mean by combination of these two processes, these two functions? So let A is subset of R. A function f from A to R is said to be increasing. Is said to be monotonic increasing if for x1 x2 in domain x1 less than x2 implies f of x1 is less equal f of x2. Right, so function is monotonically increasing means what? If, for example, see this figure, if this is my function, right, this is a graph of function. Now if I select some x1 and some x2, Right, x1 is less than x2. Is it true? Correct. Now where is f of
Yes.
x? So value of function at x1 is on y-axis here, and value of function at x2 is on also on y-axis here, right? So x1 is less than x2, and f of x1 and f of x2, what is the relation which is bigger? F of x2 is bigger, right? Maybe equal sometimes. Here it is strictly bigger. Look at another situation. Another situation could be like this, right? So x1 is here, x2 is here, right? fx1, fx2. So here also x1 is less than x2 and f of x1 is less than f of x2. Correct. So therefore both of these graphs are graphs of increasing functions. So if you look at f of x is equal to sine x, is it increasing function?
No.
No, right? So because if you look at graph of sine function, then graph is like this, and if you observe that 0 is less than 3 pi by 2, so 0 is less than 3 pi by 2, but f of 0 is greater than f of 3 pi by 2. Correct? What is f of 3 pi by 2 minus 1, and f of 0 is 0. So this is x1 and this is x2. x1 is less than x2, but f of x1 is not less than, f of x1 is greater than. So not increasing. And you observe the nature, function is increasing means if you increase the variable x, the value is going up and up. So not increasing. But if you look at another function, f of x is equal to fx is equal to x defined on R. Is x increasing? What is your answer?
Yes.
Right. So if you look at graph of fx is equal to x, then this is a graph, and you observe that if x going up, the x is increasing, values are increasing. Now f of x is equal to 5, constant function. What is the graph of this function?
Horizontal line.
Horizontal line. Right. 5. Y is equal to 5, horizontal line. Now is it monotonically increasing?
No.
No.
What is the definition of monotonically increasing? If x1 less than x2, f of x1 is less than or equal to, maybe equal, that is also fine. Suppose this is x1 and this is x2. So x1 is less than x2. But what is f of x1 is 5 and f of x2 is also 5 because everywhere value is 5. Therefore, f of x1 is, you can say that f of x2 is less, x1 is less equal to x2. Equal means either less or equal. Correct? So constant function is monotonically increasing.
Sir,
Yes.
sir, what is the meaning of the meaning word monotonically? As we said, it's monotonically increasing.
Monotonically means either it is equal or greater. Going up or remains constant. So monotonically. It is not, the monotonically means it is not going down, it is going up, or see, monotonically increasing means not going down. So not going down means what? Either it may go up or remains stable, but not going down, right? Or
Okay, sir.
non-decreasing, right? So non-decreasing means what? It is not decreasing, it may increase or may remain stable, correct? So a function f from a to r is said to be strictly increasing if for x1, x2 in domain A, x1 is less than x2 implies fx1 is strictly less than fx2. Now this is a difference. There is a difference between previous monotonically increasing and strictly increasing, right? So strictly increasing. Do you understand now? So fx is equal to 5 is not strictly increasing, correct? If I define function from minus pi by 2 to pi by 2 to r, what is f of x is equal to sine x? Is it increasing? Yes or no? What is answer? Yes.
Yes.
Yes, because if you just restrict the domain minus pi by 2 to pi by 2, and in that region, what is the graph? Graph is like this. So we are not worried about the points outside this interval minus pi by 2 to pi by 2. We are worried only inside this. And therefore, in this range, it is strictly increasing, no doubt. Correct? So f from r to r defined by fx is equal to x upon square root of is f strictly increasing. What is the answer? Is f strictly increasing? If answer is yes, prove it, or not, then also prove it. So what about this function fx is equal to x upon square root of 1 plus x square? Is it monotonically increasing? What is your answer?
Yes, sir.
Yes, because if you see the graph is like this. Anyway, it is going to increase it, but you should prove that. So what you should prove? Try to prove that what you should prove if a less than b, then a upon 1 plus a square is less than b upon 1 plus b square. This is the inequality for real numbers. Try to prove it. If you are able to prove, then we can say that function is strictly increasing. Right? But you have already proved this, so in some sense, just work it out. F of x is equal to x. Is it increasing? Strictly increasing?
Yes.
Yes. Right? So if I define f from R to R, fx is equal to x square. Is f increasing? Is f increasing? F of x is equal to x square. See the graph. See the graph of x square. Is it increasing?
No.
No, sir.
No. Because
No, sir.
minus 1 is less than 5. Minus 5, minus 10 is less than 5, but f of minus 10 is greater than f of 5. There are many such things because if you observe the graph, here it is going down and then it is going up. Increasing means it should be going up and up, right? But in second case, is it monotonic increasing or increasing? Strictly increasing?
Yes.
Strictly.
So, right. And second case answer is yes. So why? So you should write down the proof, explanation. Because we are just in our domain is only 0 to infinity. Therefore, negative side is not in the domain. So the situation like minus 10, 5 will not arise in this case. So it is increasing. Right. A function f from a to r is said to be monotonically decreasing if for x1 x2 imply in a x1 less than x2 implies if x1 is greater equal f of x2. So just opposite that process of increasing. So if you look at this function, suppose graph is like this, and if this is x1 and this is x2, then look at where is f of x1 and where is f of x2. So x1 is less than x2, but what is relation between f of x1 and f of x2? Do you understand what is the relation?
f of x1 is greater than f of x2.
Right, so it is greater than, so it is decreasing. Or you look at another graph like this. So x1 and x2. So where is f of x1? Here it is f of x1 because y component, just horizontal line. Where is f of x2? Y component of value at x2. So f of x2, right? So x1 is less than x2 and f of x1 is greater than f of x2 in this case. So this function is decreasing, monotonically decreasing. So f of x is equal to 1 constant. So is f monotonically decreasing? Is answer
Yes.
Monotonically decreasing means non-increasing. So if I define f from R to R, fx is equal to sin x. What about f of x is equal to minus x? What about f of x is equal to minus x? Do you know graph of f of x is equal to minus x? Y is equal to minus x. This line, correct? What about sin x? What about sin x?
Not decreasing.
Not decreasing. But if I define sin x f from pi by 2 to 3 pi by 2 to R, fx is equal to sin x, is f decreasing? Yes. How is the
Yes, sir.
graph? So how is the graph from pi by 2 to 3 pi by 2? In this range graph is like this, right? Here it is like this. After that it is going up, but we are interested in only minus pi by 2 to 3 pi by 2 to 3 pi by 2. That is only point of interest. So in this case, minus pi by 2 to 3 pi by 2, it is decreasing. That is clear. Okay, so a function f from a to r said to be strictly decreasing if for x1 x2 in domain x1 is less than x2 implies f of x1 is strictly greater than f of x2. And then look at the previous examples which are strictly decreasing, right? Definitions are clear. Definitions clear.
Yes, sir.
Now, so observe if f is increasing, suppose function is increasing or strictly increasing, then what will happen? Its graph is just going up and up. Is this function 1 1 then? Is this function?
Yes.
Yes.
Sir. Yes.
Yes.
Then f is 1 1 or injective, right? And so therefore if f from a to r, where a is subset of r, is strictly increasing, then f is 1 1, right? So if function is strictly increasing, then function is 1 1. So what will happen in this case? Suppose f is strictly increasing, right? Therefore, x1 less than x2. Therefore, for x1, x2 in domain, x1 is less than x2 implies fx1 is strictly less than f of x2. What is our claim? What is our claim? F is 1, 1. F is 1, 1 or injective. This is our claim. Suppose f is not 1, 1. Suppose not 1, 1, then we should get some contradiction. If f is not 1, 1, then what will happen? What is the meaning of 1, 1 and what is the meaning of not 1, 1?
x1 does not equal to
Yes,
x2.
no. F is
F
1,
of
1 means what?
If the
X
images
is
are
not
x1
equal
equal to
x1
to
x.
y.
equal to x.
images are associated.
X is not equal to y, then fx is not equal to
Not
fy.
equal
If
to
points are distinct, their images are distinct, right? And f is not 1, 1. What is the negation of this? What is the negation of this? For any x and y, for any pair, if points are distinct, images are distinct. That is a definition of 1, 1 function. What is the opposite to that? Not 1, 1. Then what is the opposite of this definition? Negation. For any
x.
xy, if x is not equal to y, then if x is not equal to fy. For any, it fails not for any, for not every pair xy means what? What is the negation?
If x is not equal to y, then f of x equals to f of y.
See, what is the definition of 1, 1? For any xy pair, this is going to happen. Suppose I say that suppose I give a box containing fruits and I say that every fruit in this box is every fruit in the box is sweet. What is the negation of my statement? When my statement will fail?
If one fruit is not sweet.
If you can produce at least one fruit which is not sweet, then my statement will be false, right? When I say every fruit is sweet, but if you can produce at least one fruit. So when I say that any pair satisfies this condition, x not equal to y, then x fixed. So when this statement will fail? When this statement will fail?
If there is
If
at
any
least one
element
pair
has or more
where x is not equal to 1,
Here
implies f of x1 is equal to f of y.
exists x and y in A such that they are unequal, but the images are equal. Right? That is what not 1, 1. Because in case of not 1, 1, what we observe there are two elements x and y which are not equal, but their images are equal. Right? Both have same image on y-axis. That is what happening if function is not 1, 1. So now when I am saying that f is not 1, 1, suppose, then what I can say, there exist x and y in domain such that fx is equal, such that x is not equal to y, but fx is equal to fy. That means distinct points are there, their images are same. Okay, since x is not equal to y, by trichotomy property, what is trichotomy property? What is trichotomy property of real numbers? two numbers are unequal. Do you remember trichotomy property of real numbers? What is a trichotomy property? If you are given two real numbers, then exactly one of the following is true. Either they are equal, or A less than B, or A greater than B. Right? For any two real numbers, exactly one of these three hold. Is it clear? Do you remember? Do you
Yes,
know
sir.
this? Right. So
Yes.
for any two real numbers, either they are equal, or one is less than another, or first is greater than. So this is what property. So suppose x and y are real numbers, and x and y are unequal, then what are the possibilities? Either
X is greater than Y or Y is greater than X.
y is greater than x, but not both simultaneously, right? It is not possible that some number is greater than x is greater than y and y is greater than x simultaneously. That is not going to happen. Exactly one of the three things is possible. Either they are equal, or less, or greater. Anyway, so first case, if x is what? If x is greater than y. If x is greater than y, then so suppose y is here and x is here. X is greater than y. Then what?
F of x is greater than f of y.
Because what is our assumption? F is increasing. This is our assumption, right? Therefore, f of x is greater than f of y. That means f of x is not equal to f of y. Contradiction. Right, because we are assuming that x and y are such that fx is equal to fy. But our basic hypothesis is key function is increasing, strictly increasing. And if x is greater than y, f of x is greater than f of y by increasing nature. So that means fx is not. So contradiction. What is second possibility? What is second possibility? X is less
Y
than
is
y.
greater than X.
Then since nature of function is increasing, fx is less than fy. Again, fx is not equal to fy. Contradiction. Right. So in any case, there is a contradiction. So what is the conclusion? What is the conclusion? What is the conclusion? See,
Our
again,
If a
assumption is
go
wrong.
function is straightly increasing, then it is 1 1.
1 1 because such pair will not exist. Which pair? Key points are distinct, but values are same. Such pair does not exist. Therefore, there does not exist. There is no pair xy in A such that there is no pair of points xy in domain such that they are unequal but values are same. Such pair does not exist. That means this imply, what does it mean logically? This is a logical way of thinking. So there is no such pair. That means what happens for all pairs? What will happen? X not equal to y implies fx is not equal to fy. Right? There is no pair such that the points are distinct but values are equal. That is not going to happen. Means what? For any pair, if points are distinct, then values are also distinct, and therefore f is 1 1. Is it clear? Proof is clear.
Yes, sir.
Very good. So therefore, if function is strictly increasing, then certainly this function is 1, 1. And therefore, there is another way to look at the 1, 1ness. What could be the analogous statement? What could be the analogous statement? If is
The function is 1, 1, then it is strictly increasing.
function is 1, 1. No, that is converse. Okay, if function is strictly decreasing, then f is 1, 1 by same logic, correct? So you write down the proof by similar lines. Now question I would like to ask is the converse true of the converse true? That means if function is 1, 1, does this imply it is strictly increasing?
No.
For example, what is the theorem? If function is strictly increasing, then it is 1, 1. Now, if it is 1, 1, is it strictly increasing? Yes. If function is 1, 1, is it strictly increasing or strictly decreasing? That is, if f from A to R is 1, 1 or injective, does this imply f is strictly increasing, right? Or if f from A to R is 1, 1, does this imply f is strictly decreasing? Is the converse true? Now I will give you hint. You have to find out example. I will give you hint. Suppose my A is 0 to 1, union 3 to 4. This is my domain. Do you understand what is my domain? A is 0 to 1. This is my domain of function. And here somewhere 3 to 4. This is domain. Outside it is not in the domain. Remember this. This is my domain. Okay, now I will define a function so that it is 1, 1. For example, I will define function like this, right? And whatever it may be. So, okay. I will define function like this. I will define function like this. Is this function 1, 1? This is my graph.
Yes.
So this function is 1, 1. Is it increasing?
No, sir.
No, not increasing, because 0 to 1 it is increasing, but 3 to 4 it is decreasing. Correct? Do you understand?
Yes, sir.
Now, can you produce explicitly the function? Find such function. This is hint.
So
I have
can
given,
we consider
yes,
two graph at a time?
yes, this is a function because domain is 0, 1, comma 3 to 4, and we are going to define a function f from a to r, right? How will you define f of x on 0 to 1 and define function on 3 to 4? What is here and what is here? That is a function from defined on this domain A. Is it clear?
Yes, sir.
This is interesting exercise. You should think about it and try to write down explicit formula for this function. Okay, so our time is over, so we should stop here. If you have any doubt,